Okay, so starting off, you have some blanks to fill on your notes. The first one, an angle of elevation is formed by a horizontal line. Show me with your arm. What is a horizontal line?
Oh, the horizon.
That way.
You're thinking about the horizon.
Vertical, horizontal. So it's a flat line to a line of sight. Now, when I say elevate or elevation, what does that make you think?
Elevator.
Yeah, what do elevators do?
Go up
They
and
go
down.
up and then they go down. But if I'm talking about like the elevation of an airplane, what am I saying?
How high does it
Yeah,
go?
how high in the air is it? So it's to a point above the line. To the very top. So you got some points. And then the other one today is called an angle of depression.
Oh.
Now, what do you hear? What do you think of when you hear depression?
Sadness.
It's sadness. You're feeling
Down.
down. So once again, it starts at the same place. We always start with the horizontal line. Show me with your arm a horizontal line. Horizontal line. But it opens down.
Down.
So it's like you have a horizontal line of sight, but you're looking down at something. Okay? Now, commonly, I see people call this angle an angle of depression because it's going down, right? But why is this not considered an angle of depression? Yeah, it doesn't have a horizontal top to it. So you might write this in your notes because it's easily confused. This is not an angle of depression. An angle of depression starts with the horizontal line and opens downward. So this one is an angle of depression.
I didn't get the angle of depression.
Okay, so here we have a picture, and there's 4 angles. They're either angles of elevation or they're angles of depression. So I'm going to call elevation red. You can label them however you want, but which of these would be considered an elevation angle? Ryan, what's one of them? Not 1. 2 would be because the horizontal line is below it and it's opening up, right? So 2 is an angle of elevation. What else? Angle 4. So horizontal line opening up. So angle 4 is also an elevation. Which means, I'll do it in blue, the depressions are 3 and 1. So horizontal line opening down is 1, and horizontal line opening down is 3.
Wait a minute. Hold on.
You just have to see if the angle is above the horizontal line or below it. That's angle of elevation or depression. So, I have some pretty pictures up here. You don't have to picture. But basically, we're just going to read these short little scenarios, and we're going to draw our own pictures. You can get as creative as you want. Has anyone been to Seattle before? Yeah? You go on the Space Needle? I'd have to look at it, but it's like built to sway back and forth like a certain amount. Like you can feel it at the top when you're at the very top of it. But the Seattle Space Needle, it casts a shadow, and it's 67 meters. So go ahead and draw a Space Needle, or if you're not an amazing artist, just draw a vertical line. And this Space Needle has a shadow, so kind of down here. That's my shadow. And how long is the shadow?
67 meter.
It's 67 meters. So I'm going to label that as 67 meters. There's an angle of elevation from the tip of the shadow. So where in this picture is the tip of the shadow? There. Where's there? Up here? No, the tip of the shadow. So there's my horizontal line right there. And from the tip of the shadow, there's an angle of elevation, which means looking up to the top. And how many degrees is it? 70 degrees. So this here is a 70-degree angle. Now, how do we know that this is a right angle? Yeah, it's a vertical tower and a horizontal shadow, so we can assume that's a right angle. So now we just have to see what it's asking. It's asking me how tall is the Seattle Space Needle. So where does my variable go? Where does x go? Yeah, that's the Space Needle right there. How tall is it? And now that we're done with that, we're set up. We have a triangle. We have a right triangle. We know an angle. We know one side, and we're trying to find the other side. So from here on out, this is nothing new. So from that angle that we know, what is x? Opposite. What is 67? So OA is tangent. So tangent of is equal to if x is up high, we know we need to multiply. So in your calculator, you need to do 67 times tan of 70, and that is what x equals. That is how tall the Seattle Space Needle is. Does it say how to round? Nearest meter. So what are we going to call it? 184. It's a real life application, so give it units. It's 184 meters. Have you guys seen this artist before?
I probably cracked a lot across that.
No, it's a sidewalk chalk artist. I forget his name, but that's just a sidewalk. Like you can see, it's all chalk. You can look him up online.
Wait, it
He's a
washed
ton of
what?
it. So like, I drew this picture. I drew this picture because we're talking about an ice climber at the edge of a crevice. So basically, there's like a big empty space in between two glaciers or ice, whatever we call them. So Mr. Ice Climber Man is standing right here.
He's already on the edge.
Yeah, he's done for.
He's on the edge of the crevice. Now it says he has a horizontal line of sight. Well, I guess it doesn't say that, but we know that because of this. So first of all, something that we can label, the crevice is 115 feet wide. We know that. So if you don't want to draw an ice crevice, you don't have to, but draw a horizontal line. We know that's how wide it is. And now it says his line of sight is an angle of depression. What does that mean? Down from the horizontal line to the opposite side of the bottom of the crevice. So down here somewhere. This is his angle of depression. And that is 52 degrees. The question is asking me, how deep is the crevice? So this would be straight down. How deep is the crevice? So here's our right angle. Now where is x? Sometimes I'll have people put an x right here. Is that how deep the crevice is?
No.
No, deep is talking about up and down, right?
Yep.
So Avery, where am I going to put x at?
And there's one.
Where?
One spot.
Where's it at?
Where the X is.
Okay, that's wrong. You're on yellow now for your stoplight. For the stoplight, X would go over here if you're paying attention. So now, from angle 52, what two sides are we using, Ryan? OA. So this is another tangent, right? So tan of 52 is equal to opposite over adjacent. X is up high, we know we need to multiply, so this is just like the other problem. 115 times tan of 52 means x is about, now it says round to the nearest foot. 447? 147 feet.
Why did you say about? Why can't you say
Because it's not exactly. That decimal is exactly it. But and that decimal goes on forever. So if you're ever rounding, that means about. Now, I could have asked you something like, I don't know, if he needs to throw a rope from here to the bottom of the opposite side. So in that case, let's say x was here. What trig function would I use? Cosine, right? 115 is adjacent, x is the hypotenuse, ah, cosine. So you have, the whole point of today is to kind of be able to read these things and form the picture, form the triangle, know what to label where, and then solve for the missing value. Okay? We're going to save example 4 for next class. So that's all for today.